The important applications of solvent extraction are as follows. The first application is the determination of iron as iron 3. Iron 3 can be separated from most of the mono and divalent cations by extracting it from 6FHCl into diethyl ether, diisopropyl ether, or dichlorodiethyl ether. In the presence of hydrochloric acid, following equilibria exists, though its parent form is represented as FeCl4, FeH2O whole 6, 3 plus. If HCl concentration is 4F or greater, the last equilibria, which is FeH2O whole thrice Cl3 plus Cl minus, under reversible conditions gives FeH2O whole twice Cl4 minus plus H2O is dominant. In diethyl ether, it is HFeCl4 which is stable on account of low dielectric constant of ether. The species in fact varies from HFeCl4 whole twice to HFeCl4 whole 4 depending upon the total concentration of the iron present. HCl is also probably involved in the mechanism as it is extracted into ether. The acid concentration 6FHCl is very important for the successful extraction because there should be enough concentration of chloride ions for conversion of iron 3 to FeCl4 in aqueous phase and enough acid for its conversion into HFeCl4 whole n in non-aqueous phase. Other metals which are separated from aqueous HCl into ether are arsenic 3, gallium 3, germanium 4 and etc. The second application of solvent extraction is the determination of nickel as dimethyl glyoxime complex. Nickel 2 forms red dimethyl glyoxime complex in a slightly alkaline medium with DMG. The DMG is a weak monoprotic acid in water. That is, HL gives H plus L minus ions. The extraction is affected by the magnitude of formation constant of nickel 2 chelate in aqueous phase, expressed by the following expression. The chelate is slightly soluble in chloroform. The optimum pH range of extraction of nickel 2 complex is 7 to 12 in presence of citrate. The complex absorbs at 366 nanometers and also at 470 nanometers. The next application of solvent extraction is the determination of nickel by synergistic extraction. Now, nickel is rapidly and quantitatively extracted using dithiazone and 110 phenanthroline over a broad pH range of 5.5 to 11. It forms a highly colored mixed ligand complex having an absorption band at 520 nanometers. The complex is enough stable to permit the removal of excess dithiazone by back extraction with 0.1 molar sodium hydroxide. The molar absorptivity of the complex is 4.91 into 10 to the power 4 per moles per centimeter, which makes the method very sensitive. Next application of solvent extraction is the metal extraction by oxine. Oxine or 8-hydroxyquinoline exists as zwitterion. Trivalent metal ions form neutral complexes with 3 molecules of oxine, while only 2 molecules of the reagent are required for divalent metal ions. Example: cadmium, copper, nickel, magnesium, etc. The selectivity of the extraction is enhanced by using EDTA or cyanides as masking agents. Determination of urea using oxine is another important application of solvent extraction. Uranyl nitrate is taken up to an amount of 900 milligrams at a pH of 8.8 in presence of ETTA. Wavelength for maximum absorption is 400 nanometers, and EDTA is used as a masking agent for iron 3 and aluminum 3. Solvent extraction technique has also been successfully employed for determination of copper as diethyl dithiocarbamate, in which the solvent used for extraction is chloroform, carbon tetrachloride, or N-butyl acetate. Lambda max is at 435 nanometers for chloroform or carbon tetrachloride, and if N-butyl acetate is used, then lambda max is at 560 nanometers. Iron 3 does not interfere in this case, and pH is maintained at a value of 8.5. Solvent extraction is also used for extraction of beryllium as acetyl acetone complex. Solvent used is a chloroform with lambda max at 295 nanometers. EDTA is used as a masking agent and prevents the interference by iron, aluminium, chromium, zinc, copper, lead, silver, cerium. pH is maintained at between 7 to 8 and the complex is colorless. Solvent extraction is also used for extraction of lead as dithiazone complex, where pH is maintained at 9.5, lambda max is 510 nanometers. Copper and zinc do not interfere, and the solvent used for extraction is chloroform. Another important application is the extraction of molybdenum as thiocyanate complex. The complex is red in color, the composition being MoSCN whole 5, lambda max is at 465 nanometers. Solvent used for extraction is isoamyl alcohol. Another important extraction is extraction of copper as neocuprine complex. Neocuprine is 2,9-dimethyl-1,10-phenanthroline. The solvent used for extraction is chloroform. Lambda max used is 457 nanometers. pH is maintained at a value of 4.